video is to review solving absolute value equations algebraically and graphically. So we're going to solve this absolute value equation. One of the most common mistakes with solving absolute value equations is that students want to go ahead and set up their two equations right away from the very beginning, because we know that we have to set up two equations, one equal to the positive value and negative value, but we can't do that in this case right away. What we have to do is get our absolute value all alone. So what we're going to do here is we're going to add our 4 to both sides. So we have 2 times the absolute value of 3x minus 5 is equal to 16. And we still have one more step before we can set up our two equations. We're going to divide both sides by 2. So I'm going to divide by 2, and then I will have my absolute value all by itself. Absolute value of 3x minus 5 is equal to 8. So now I've isolated my absolute value, and I just have that equal to 8. And this is where I break apart into my two equations. 3x minus 5 is equal to 8, or 3x minus 5 is equal to negative 8. Because those are the two scenarios that would make this equation be true. And now I'm solving it like a regular equation. Okay, I'm adding 5 to both sides. So I get 3x is equal to 13. And then I'm going to go ahead and divide by 3. So one of my values is x is equal to 13/3. So that's one of the scenarios that makes this true. I'm going to do the other side here where I'm going to add 5 to both sides. And this is, the same process here. Negative 8 plus 5 gives me negative 3. And then I divide by 3, and I get x is equal to negative 1. Okay, I want to remember that this is an or scenario. Equals means or. So I have x equals 13/3 or x equals negative 1. I can see that this is the true case, negative 1 or positive 13/3. And I just want to take a look here what the graph looks like. Okay, negative 1, I just have a dot on negative 1. And 13/3, that's approximately 4.33, repeating. So that's why it's just a little bit past 4. So sometimes they will give us the solutions like this. Sometimes they will just give us the dots on the graph, the points on the graph, and we have to be able to determine where those points are. We're going to do one more example here with our absolute value scenarios. So again, we want to go ahead and subtract 8 from both sides. So we get 2 times the absolute value of 5 plus x is equal to negative 8. And then we want to divide both sides by 2. So we get the absolute value of 5 plus x is equal to negative 4. Now, this is one of our special cases. We know that an absolute value always has to be positive. It can never be negative. So if we get down to where we have our absolute value all by itself is equal to a negative number, we know that that can never happen. So that means there is no solution. So the way that we would represent that with our set notation would be empty brackets. That's no solution. If we look at our answer choices here, which of these represents no solution? It's answer choice A, because there are no points on our number line. Okay, it can't be any of these. A lot of times, especially when you get caught up in testing, you just go ahead and make your two equations and you solve them, and that would be wrong. So you really want to pay attention here. If your absolute value is equal to a negative value, that's a special case, and that means you have no solution. So that's either represented by the empty brackets. It could also be represented by a 0 with a slash through it, or it could be represented by an empty number line. If you have more questions on how to solve absolute value equations, please see your math teacher.